So we'll look into covariance first and then correlation. Okay. So this is a piece of, so we're going to bring in another data set which is interest rates over time, right? And this data set goes back to the same, I guess, years as we have for the different asset classes, right? And and what is interest rates, right? So interest rate is basically, let's say you get to borrow. So don't worry about this piece of code. Okay, this is just to get to a point, and you'll learn some of these things later on to be able to uh, code a little bit, right? And you're going to be doing a lot of it later on in the course. So don't worry about that piece now. I guess that entire thing is done just to get to these two plots, which is showing the interest rate on one side and what the $1,000 invested in U.S. large company stocks have done since say 1970. Right? You can sort of see that interest rates are basically in the 70s they sort of spiked up, and I'm not sure whether you have read about it in the decade of that 70. There was stagflation, pretty high inflation during the during the Nifty 50 era and the Jimmy Carter's administration until I guess Ronald Reagan came to power and so on. And from that point on, this country has seen, and this country and probably the world has seen a relentless decline in interest rates since then. And today, so this one was collected at 2018. Today the interest rates are even lower, right? So they are almost touching zero, right? So what does it do? Like, so if you're running a business, for example, right, and you get to borrow, your cost to borrow every year is steadily declining, right? So what that does is it gives you added firepower in terms of growing your revenues and profits, right? So that is exactly what has happened. That is one of the reasons why you see a relentless climb up in the value of your portfolio, because part of that is the fact that your cost to borrow has relentlessly declined, right? So as interest rates went down, the value of your portfolio went up, right? So you can see there is an inverse correlation, right? Or let's talk about correlation later. We see that there is inverse covariance, right? So what do we see? So we see so there is an apparent inverse relationship between interest rates and the performance of our portfolios, right? And we'll get back to this again later on. But how do we sort of quantify this relationship, right? And so how do we quantify any relations between say two random variables, right? So we'll start with covariance first, right? So covariance basically measures the extent to which the deviation of one variable sort of varies from its mean, okay, matches the deviation of the other from its mean, right? So we have two variables because you're measuring the value of your portfolio on one hand and the interest rates on the other hand, right? So it sort of provides insights into how two random variables are in a data set are related, right? And how they change together, right? So of course, a positive covariance means that the two variables actually go up and down in sync. Okay, and negative covariance basically means that the two variables act opposite of to each other, right, in the opposite direction, right? So let's assume we have x and y as two random variables. Okay, and the covariance between the two is calculated as expected value. Okay, this is again getting into that same expected mean business, right? Expected variance, expected mean business, right? So what do we have? Okay, so this is the first variable from its mean. Okay, so this is if you have say 10 data points, right, you will calculate the mean. Okay, that comes here. Okay, for each of those data points you're going to have a value of x minus ex. Okay, and then you have another column with 10 data points. You will, for each of that data entry, you will have y minus ey, and the mean of the product of these two is covariance. Okay, so I know it's a little bit of a long worded thing. Okay, let's pull out our Excel. Okay, we can do it in here, but let's do it in Excel. Okay, so let's say you have one random variable which has value 5, 4, 3, 2, 1. Another random variable y which is 1, 2, 3, 4, 5. Okay, and we are going to put this side by side. Okay, and x minus ex, we are going to calculate that for each row. Okay, 2, 1. So x minus ex is this, right? So this is our ex, just to make sure we are calling it the same, ey. Okay, oh sorry, this is also ex. Okay, ex and ey. Okay, because this is ey. Okay, so let's call this ey. Actually, let's just say ex and ey. Okay, in the same row. Okay, I hope it's not confusing. Okay, and let's make it a little big. Okay, so we have 5, 4, 3, 2, 1 and 1, 2, 3, 4, 5. Okay, and we are calculating x minus ex, which is 3. Okay, this is the average. If you look at it, this is just an average of this column, and this is an average of this column of the y variable, right? And you're calculating x minus ex here, y minus ey here, and you're taking the product of that, which is here. Okay, and you're calculating the average of this column. Okay, which is your covariance. So this is your covariance here. So as you can see, this one is going down and this one is going up. Okay, so it's inverse correlation, right? Oh, sorry, we haven't gotten to the correlation yet. So it's inverse covariance. Okay, so that's why you have a negative sign. Okay, now in this case you have this going up, 1, 2, 3, 4, 5, and this one also going up. So there is a positive covariance, right? So that's going up in the same direction, right? So this is basically the covariance business, and this is the same thing. You know, you're trying to simplify it because most of the time you're going to be dealing with a data set, right? And the data set will have rows, and depending upon the number of rows, you can just do so this pi just becomes 1 over the number of rows, right? Which is the probability of each instance happening, right? So this is the formula to calculate covariance. Okay, and that's when the two variables are x and y. What if the two variables are the same, right? Let's say you are trying to find a covariance with respect to that same variable, right? X and x. That gets us to the variance formula we already talked about, right? So the covariance formula is a more general form of defining both variance and covariance, right? So I hope this covariance is business is clear, and I hope we started off as a way to explain as to what it is conceptually just by looking at a plot of two variables, right? And we're going to talk a little bit more about covariance and then move on to correlation. Okay.